Hello. So today we talked about special right triangles, and they're going to be a little hairy. We're going to be doing special right triangles for today and then all next week. And I'm actually going to show you some shortcuts and some tricks next week. But today we're going to do it the long way because you need a foolproof method that is going to work every single time. So that's what I'm going to show you today. Okay? So with special right triangles, there are actually two kinds of special right triangles. There are 45, 45, 90 triangles, and there are 30, 60, 90 triangles. And I'll tell you, when you get into like Algebra 2, Pre-Calculus, and Calc, these triangles show up a lot because they're used in trig. Okay, so that's why we're going to be talking about them. So we need to know how they work and what they look like before we can start talking about trig with them. But what this basically means, 45, 45, 90 triangle is a triangle, and it is a right triangle, but it's a triangle that has a 90-degree angle and then two 45-degree angles. Now, if those two angles are the same, then you know that this is an isosceles triangle, and so this is a right isosceles triangle. And the really cool thing about that is that in a 45, 45, 90 triangle, the side lengths actually have a very specific ratio to them, okay, a very specific ratio. Same thing with a 30, 60, 90 triangle. So let me show you that. So that means that there's a 90-degree angle, there's a 30-degree angle, and a 60-degree angle in it. And we did talk about a long, long time ago, right? The smaller the angle, the smaller the side is across from it. So if 30 is obviously smaller than 60, the side across from it is going to be smaller than the side that's across from the 60, okay? But these also, the side lengths have a very special relationship between them, okay? They actually, the really cool thing about this one, and this is one of the tricks that we will be utilizing next week, but one of the things with the 30, 60, 90 triangle is that the side that is opposite of the 30-degree angles on the other side, this side length is actually half of the hypotenuse. So if this side length is 1, then this hypotenuse is 2. It's always half. If this side length is 5, then this side length would be 10. It's always half. And that's one of the little tricks and things that are going to pop up next week. Now, in class, we spent a little bit of time and we did some Pythagorean theorem using a 1, a 2 to figure out what the side length of this is. You are welcome to do that. You're welcome to double check if you want, but the side length over here, after you do Pythagorean theorem, ends up being a square root of 3. Now, in order to keep things consistent and keep things the same, so this hypotenuse is a 2. If we labeled our 45, 45, 90 triangle with a 2, and then did, again, some Pythagorean theorem, you would get these two side lengths to be the square root of 2. And so what we need to do today, and what you need to make sure that you do today, is that you recognize and use these two triangles. So you kind of have to remember what those side lengths are in order to find the side lengths of some other special right triangles. So let me show you what I mean, what in the world I'm talking about, okay? All right, so here's what I'm actually talking about. Ooh, let there be light. Okay, so here's what I'm actually talking about. So this first triangle right here, this is a 30, 60, 90 triangle. And if I know that this side is 5, I can use this idea in these relationships with the 30, 60, 90 triangle, and I can find out what the hypotenuse is, okay? If we have a 45 degree, right, a 45, 45, 90 triangle, I can use this idea and the relationships between the sides. If I know that one of the legs is 4, I can figure out what the hypotenuse is, okay? So again, I'm going to show you today how to do the foolproof, guaranteed, it's gonna work every single time method. And then next week, I'll show you how the shortcuts kind of work, okay? All right, let's go get started. All right, so you know, Hunsaker, there is a method to the madness, I promise, okay? So here's what we're gonna do. And this is how I want you to do these problems, okay? So starting with the first one, what I'm gonna do for this particular problem is I'm actually going to draw this exact same triangle in the exact same position on my paper. So facing the same direction, okay? That's what I'm gonna do. I'm gonna draw every single one of them facing the same direction, okay? So here is this triangle, and this is my right angle, this is 30, this is 60. What I want to do is I want to take my triangle that I just wrote, and I want to write down and label it with our special number. So you need to have this memorized, basically. The more you do it, though, the more you'll have it actually memorized. But remember, it goes across from the 30 degrees is 1, the hypotenuse is 2, the other side is root 3. Okay, so if I label this with our numbers, across from the 30 is a 1, hypotenuse is a 2, this is a root 3. And here's what is really cool about it. Once you have it labeled, you now have two similar triangles. Remember, with similar triangles, all the angles are the same. And what happens is you can make fractions and set up proportions with the sides that are in the same position. Okay, so we did this quite some time ago. Okay, so we're just going to write a fraction and go solve this problem. So we're going to put x over 5, right? And that's going to be proportional to 2 over 1. And now it's just a matter of cross multiplying, dividing, and solving for x. So I get x to equal 10. Okay, this is the foolproof, guaranteed, gonna work every single time. The trick that I'm gonna show you next week is gonna be where, I don't know if you remember me telling you when we went to label our first triangle, but across from the 30-degree angle, this side is always half the hypotenuse, and so the hypotenuse ends up being a 10. The problem with the tricks is that you gotta remember them. Got to remember how the tricks work, and I don't always remember them. So this is going to work every single time. Let's go do it again, okay? Let's go do letter E. So again, I'm just going to fold this out of the way so that I can see it a little bit better. But what we're going to do is we're going to draw that triangle again. So we're going to go draw the triangle for letter E in the same position that it is. Okay, it's almost like I'm tracing it. So I have a 60. Here's my 90. This is a 30. And I'm going to label my triangle with our numbers so that we can just really easily see what matches up for our fraction. So remember, on our triangle, across from 30 is a 1, hypotenuse 2. That makes this root 3. So my ratio, my proportion is going to be x over 3 root 3 and then 1 over 3. So I'm just setting up a proportion to get it solved. I will tell you that sometimes the hairiest part is just trying to figure out how to actually solve it, right? So drawing the triangle, labeling the triangle, and even writing the fractions, not so bad. It's the next step that can sometimes be a little hairy. But let's go cross multiply. So we get x times root 3. 3 root 3 times 1 is just 3 root 3. Oops, I'm off the page. Sorry about that. So we're going to go divide by root 3. And the nice thing is this cancels, and we get x to be 3. Okay? So our first one was 10. This one is 3. Make sure that you're finding your answers down below and actually fill them in. So this big black square means that where the 10 is, you're just going to block that square in. These are just going to be the spaces, it looks like, between our words. Okay, but make sure that you're finding your answers. I want you to be able to check your work and see. It looks like there's only one 3, and that's going to be here. Okay? All right, let's go do letter K. All right, so with letter K, this is a 45, 45, 90 triangle. And so this one's going to be labeled, remember our hypotenuse is 2, and then our legs are root 2s. And then again, now that we have it, we can just set it up. Okay, so x over 9 is going to equal root 2 over 2. Do some cross multiplying, and then divide by 2. And so for this one, for letter K, there's your answer. It's going to get a little bit hairier as we kind of go. Letter A should be relatively easy. You're just trying to figure out what this angle is, knowing what the other one is with it. Let's go do the exclamation point problem at the top. So let me fold my paper so that I can draw that triangle right there with it. Okay, so here's this one. This is a 45, 45, 90 triangle again. And so I'm going to have 2 and then root 2s. And then x over 4 equals 2 over root 2. Make sure when you set this up, right, that you've got the right things in the right place. Everything should kind of line itself up, okay? All right, so we're trying to find out what this length is. Let's go and solve this proportion. So I'm going to cross multiply. So x times the square root of 2 is just x root 2. 4 times 2 is 8. And then we're going to divide by root 2. Now, here's the method to the madness. This is why we spent all this time doing these radicals, right? You're not allowed to have a radical in the denominator. So we have to rationalize the denominator. So this becomes 8 root 2 over 2. 8 divided by 2 is going to reduce to a 4 root 2. Okay, so for for the exclamation point, if this side is 4, this side over here is 4 root 2. Okay, again, I'm going to show you some shortcuts next week. All right, letter W is another fairly easy one. Let's go do letter Y. So I'm going to draw the triangle to match. It's a 30, 60, 90 triangle. Across from my 30 is 1, hypotenuse 2, this side root 3. And I'm going to have x over 7 root 3 equal to 2 over the square root of 3. Okay? All right, let's go solve this one. So let's do some cross multiplying. So I get x times root 3. 7 root 3 times 2, I can do 7 and 2, which is 14. When I divide by the square root of 3, oh, thank goodness, I don't have to do much. I get a 14. That's nice. Okay. All right, so I kind of jumped up to letter I, because letter I is another one that's a little on the hairy side. So I just wanted to jump up and kind of talk to you about this one. So I drew the 45, 45, 90 triangle. I labeled it with my numbers, and then we're going to go set up this proportion and solve. So we're going to have x over the square root of 3, and because I did x first, I have to do 2 first. So 2 over the square root of 2, okay? And so this is the proportion I'm going to solve. So let's go figure that out. So when I cross multiply, I'm going to get x times the square root of 2. 2 times the square root of 3 becomes 2 root 3. And now I have to divide by the square root of 2. Again, you can't have a 2 in the denominator, so we have to rationalize it. So we're going to multiply by the square root of 2 over square root of 2. We're going to get 2 root 6, because remember, you can put those together. The square root of 2 and square root of 2 becomes the square root of 4, which is 2. And then your 2's can cancel out, so this final answer is the square root of 6. Your job is to get this riddle, to get these problems and try these problems. I will tell you that the answer to the riddle is that you must know your side ratios. So I want to see on your paper when you go to submit it, I want to see all of your triangles. I want to see the proportions that you're using to solve them. and then see if, as you go through and do them, that you can get those numbers and those answers to work out. Okay, so I want to make sure that you're setting them up correctly, that you know how the foolproof method works before I show you those shortcuts.